In this video, we're going to continue looking at how to factor polynomials, specifically trinomials, then a little bit of four terms, that type of thing, but let's focus right now on trinomials. Now, in the previous video, we talked about how to factor out something that's in common. But we're going to move on to another type where if it's got a lead coefficient of a 1, there's a fairly standard but kind of quick way to get it factored. But I want to go back and kind of remind you about when you first started finding factors, because sometimes it helps just to put it in context with what you already know. So way back yonder, somewhere in elementary school, first they taught you how to multiply, and they taught you something like 3 times 4 is equal to 12. So they said, okay, the product of 3 and 4 are 12. And then they said, well, let's try to find something that multiplies to 12. So you could reverse that and say 12 is 3 times 4. You could also say it was 2 times 6 or 1 times 12. So these that are over here are the factors of 12, right? Now, the way you get them, if you're a little, like when you very first started learning this, you would say, okay, what are the factors of 12 if one of them is a 3? And you would go, well, 3 times what is 12? And you would think about it for a second, or you could think of it as 12 divided by 3 is 4, so the other number is 4. So you can divide out one of the factors in order to find the other. That's kind of what we did when we were finding the greatest common factor in the previous video. Now, what we're going to be working with are two binomials such as this. So you would have learned how to multiply two binomials, and there's two ways really. One of the ways has two common names to it, and the other one's a little different. So one of the ways that they would teach you to do this is what's called the FOIL method, where it says take the two first terms and multiply them together. So x and x are the two first terms, and x times x is x squared. Take the two on the outside, so that would be these two are on the outside, and so that would be minus 3x. Take the 2 on the inside, so that would be minus 2x, and then take the 2 last, so that would be minus 2 times a minus 3 is plus 6, right? So that would be the FOIL method. First, outside, inside, last. Then there's the kind of repetitive distributive property. So you would take this x times this one, x times x is x squared, x times minus 3 is minus 3x. Then you would take the minus 2 and multiply it by everybody in the second factor, minus 2x plus 6. So do you see how the FOIL method and the distributive property are actually the same method, they just have different names? All right, so the FOIL method and the distributive property are actually the same process with different names. Then this one is often called the vertical method because they're arranged vertically one over the other. But this goes back to like when you were multiplying by 12 by, say, 24, and you would go 4 times 2 is 8, and then 4 times 1 is 4. And then 2 times 4, you skip a spot. 2 times 4 is 4, 2 times 1 is 2, right? So going back to that technique, you would start here in this bottom right corner. Negative 3 times negative 2 is plus 6. Negative 3, and so you're going to go this one times this, and then this one over here, catty corner, is minus 3x. Then you're going to skip a spot, scoot over. X times minus 2 is minus 2x, and x times x is x squared, and then you would add down. So you'd have plus 6 minus 5x, x squared, and these over here are x squared minus 5x plus 6. So you get the same answer any way you do it. Now, the FOIL method only works on two 2 terms times 2 terms, because it needs a first and outside, inside and last. Does not work on a middle. Okay, so it only works on a binomial times a binomial. This idea of repeated distributive property works on anything. Binomial times a trinomial, trinomial times a trinomial, it doesn't matter. It works on everything. So does this vertical method. So this vertical method or the repeated distributive property works fine. Now, look right here. So what happened is these two multiplied to 6, right? So we multiplied to 6. Same thing here. We multiplied to 6. Now here we added to minus 5x. Same thing here. We combined these two to get to minus 5x. And then this x times this x is x squared, right? So let's use that kind of pattern here and talk about x squared plus 8x plus 12. Now in the previous video we learned how to factor out something that's in common, but this one doesn't have anything in common. But it is a trinomial with a lead coefficient of a 1. Now in the description below, in the description category, there'll be a link to all the rules on one page that I wrote up by hand, all right? And there'll also be links to practice problems for you to use, and then the previous and next video. But this pattern says, all right, if it's a lead coefficient of a 1, you know that there had to be an x here and an x here, because it would not have been something like a 2x and a 3x or something, because you had 1, not 6x squared. So it'd have to be a 1x times a 1x. That gets you the x squared. And the question becomes, what multiplies to 12 and adds to 8? So you'd go, okay, it multiplies to a positive 12, so they must be the same sign, both negative or both positive, but multiplies to 12. 1 and 12, 2 and 6, 3 and 4. Now it has to add to a positive, so if they're like signs, to multiply to a positive, so they're going to multiply to 12. And one of these pairs adds to a positive 8x. So they must both be positive. And what multiplies to 8? 2 and 6. So this would be plus and plus. And you would go plus 2, plus 6. And it doesn't matter if you go 2 and 6 or 6 and 2, because 2 times 6 is 12 and 6 times 2 is 12. So it doesn't make any difference which order they're written in. All right. Now, before you run on and turn this into your teacher, you can check these, right? Because what you would have to do is then to go over here on a scratch piece of paper and go, all right, I'm going to check this. So x times x is x squared, x times 6 is 6x, 2 times x is 2x, 2 times 6 is 12. Yep, that adds up just fine. So I feel good about that before I turn it in. Now let's look at x squared plus x minus 6. Now this is, see this one up here? That's x squared minus 5x plus 6, right? So there's a 6 here on the end. Here's a 6 at the end. But what happens in the middle is completely different because of the signs. Here it multiplies to a positive 6, so they have to be the same sign, either both negative or both positive. And so it's either 1 and 6 or 2 and 3. What multiplies to a positive 6 and adds to a negative 5? So it must be negative 2 and negative 3, right? Which is what we had. Negative 2 and negative 3 is where it came from, right? So let's go down here and say what multiplies not to a positive, but it multiplies to a negative 6 and adds to a plus 1. So 1 and 6, 2 and 3. And if it multiplies to a negative 6, one has to be positive and one has to be negative, because if they were the same sign, they'd be positive, right? Negative times a negative is positive. Positive times a positive is positive. All right, so one has to be plus and one has to be minus, and it adds to a plus 1. All right, so that means I have more positives when I get through adding. So it'd be plus 3x minus 2. So I know there's an x here and an x here because it's a lead coefficient of a 1. And to multiply to a negative 6 and add to a plus 1 would be a minus 2 plus 3. And if your brain is kind of resisting this going, then the fastest way for you to kind of get into this and for your brain to accept it and to go, okay, yeah, I'm with you now, is to keep checking these. And the more you check them by multiplying them out and seeing that you get up to here, the quicker you'll go, okay, yeah, I can see the pattern. Okay, definitely can see the pattern. So notice that the big difference is here is that they multiplied to a positive, so they had to be the same sign. They multiplied to a negative, so they had to be different signs. Okay, let's try another one. They don't have to be all x's. All right. So there's nothing in common to factor out, right? Because the smallest number here is 1. If you're not sure what I'm trying to bring up the smallest number and the smallest variable, go and look at the previous video. It's real short. So there's no r's in common with all three because this 54 doesn't have an r, and 1 is the only thing that goes into everything, right? So it's the lead coefficient of a 1, and you would put an r here and an r there. That's what you know just from the fact that it's 1r squared. And you would say what multiplies to 54 and adds to 21. So now it multiplies to a positive 54, so they're the same sign. And you would say, okay, what multiplies 54? 1 and 54. 2 goes into it 27 times. 3 goes into it 18 times. I had a student tell me one time, and they looked at some number, it was really huge, and they said, well, 3 goes into it. And I said, how do you know that? It was a huge number. I don't remember what it was. And they said, if these digits right here add to something that 3 will go into, then 3 goes into this number. And I said, oh my gosh, I'm going to tell everybody that because I didn't know it. All right. So 5 plus 4 is 9. 3 goes into 9, so 3 is going to go into 54. So there's your thought for the day. All right. Now there are other factors available, but if I'm going to add to 54 and add to plus 21, I said add to 54, excuse me. If you're going to multiply to 54, okay, so we're going to multiply to 54, positive 54, so they have to be the same sign. And add to positive 21, they both have to be plus, and 3 and 18 will do that, so I don't need to keep going into what else multiplies to 54. So I would have plus 3 and plus 18, and like I said, multiply this out and you'll get much more comfortable much more quickly than if you just run on and check it in the back of the book. So multiplying it out and seeing this process of multiplying and adding will help you to apply the pattern quicker. So let's try this one. And you go, well, this one doesn't have a lead coefficient of a 1. No. Okay. But wasn't there something in common to factor out? So what you do is you look at the smallest number that's a multiplier, and you look for the variable to see if the variable is in common with all three terms. Well, there's not an x in all three terms. There's only an x in 2, so that's not going to be common. But 2 goes into every number. 2 goes into itself, 8 and 42, so I can factor out a 2. And remember, when you factor out a 2, what you're literally doing, like when we first started talking about factors, is you are dividing it out into the front to see what your other factor would be. All right, So I've got 2. And now I have a lead coefficient of a 1. So you would say what multiplies to negative 21. So they're different signs. So it multiplies to negative 21, but it's going to add to a positive 4. So 1 and 21, 3 and 7, those are all the ones that I know. But it's going to add to a positive 4, so the bigger number is positive. And so you have to be careful. Negative 3 times positive 7 multiplies to negative 21, adds to plus 4, so I think I'm doing okay. Now, one of the common problems that I see with students is they find this 2 and then they just forget to bring it along. So don't forget that. That's part of your answer. It'll cost you points if you leave it up here and then it disappears. So since you have a lead coefficient of a 1, x squared, there's an x in the front of each binomial, and your 2 terms are minus 3 plus 7. Right. I think you're probably getting the hang of this. Let's try another one. So x squared minus 22x minus 75 has a lead coefficient of a 1. So you already know that there's an x here and an x there. And you would say what multiplies to negative 75 and adds to negative 22, right? So you've got 1 and 75, 3 and 25. Now there's, 5 will go into it, all right? But I already have the pair that I need, because if this was a minus and this was a plus, that would multiply to negative 75 and add to negative 22, wouldn't it? So there's no point to keep going. So I'd have plus 3 minus 25. Right, how about 4x cubed plus 28x squared plus 48x? And you go, well, hey, it's not a lead coefficient of a 1, but hey, 4 will go into everything there, won't it? Now, actually, 2 would go into everything as well, but 2 is not the greatest common factor. It's just a common factor. And the biggest number that will go into everything, as in the greatest common factor, is 4. And there is an x in each term, and the smallest x is this x to the first down here. So that's what I'm going to factor out. And you're literally going to divide those out of each term. So 4x cubed divided by 4x is x squared. 28x squared divided by 4x is 7x. And 48x divided by 4x is 12. So if you're kind of like, okay, what did we just do? Go back and look at the other video, all right? So don't forget the 4x you just found. You have a lead coefficient of a 1 now, so there's an x here and an x there. And you want to know what multiplies to 12 and adds to 7. Okay, now it multiplies to a plus 12, 2 and 6, 3 and 4. So they're the same sign, and it's going to add to a plus 7, so they must both be positive. So it'd be plus 3 and plus 4, or plus 4 and plus 3. All right. What about 45 plus 14y plus y squared? This was a little weird, okay, or unexpected. Let's say unexpected. All right. So if that disturbs you that the y squared's on the end, you can rearrange it and say y squared plus 14y plus 45. And if it does kind of disturb you, I want to congratulate you on the fact that this is standard form, and what you're preferring is standard form, where it has the biggest power, y squared, and the next biggest power, y, and then just constant. So this one here is standard form, proper form. Okay, this one here is improper form, but doable. Right? So if you don't like it, rearrange it, but be sure the proper pluses and minuses go with the proper numbers. So let's do this one over here on the right, since we're comfortable with this. So it's got a lead coefficient of a 1, which means there's a y here and a y there. And you would say what multiplies to 45 and adds to 14. Okay, How about 5 and 9? That work for you? All right. Now, with that thought in mind, let's wander back over here. And it technically does have a lead coefficient of a 1 because the lead coefficient belongs with the biggest powered term, whether it's in the front or the back. If it's in proper form, the lead coefficient is in the lead. If it's in improper form, the lead coefficient could be anywhere. It doesn't unbecome the lead coefficient just because it's in the back, right? Or in the middle, right? So the lead coefficient is the coefficient that multiplies the biggest powered term. So this has a lead coefficient of a 1. So there's a y here and a y there in the back instead of in the front. And you would still say what multiplies to 45 and adds to 14. So it'd be 5 and 9. And if that's kind of making you cringe, you would rewrite it like this. It's amazing how, isn't it? How sometimes it's the right answer, but it just kind of makes the hair on the back of your head kind of stand up. Okay, I think that means that you have a natural bend for math, even if you didn't necessarily think so. Here's one, a little different. This is our last one. But not the last factoring because we've got several more videos to go. Now, so let's look at this and go, okay, definitely there's stuff in common. There's an x in common with each one. There's a y of some sort in common with each one. There's, looks like 6 might go into everything. But do you see how this is a negative 6? And all the ones we've done up until now are like positive y squareds. And it doesn't mean that you can't factor it with a negative in front. It's just that it's more stressful. So let's try to make our life less stressful instead of more stressful. So it would be helpful if we factor out not just a 6 but a negative. And there's the same x in common with all of three pieces. And here's a y cubed, a y squared, and a y. So the smallest one is a y. And I'm going to write this down underneath each one so you can see it. Because sometimes if they're, pretty straightforward, we can do them in our head, but we should always know how to do it the long way so that if we're ever doing something that's just like a little bit stressful, we can reduce some of that stress, right, by doing it the longer way. All right, so we're looking right here. So negative 6 divided by negative 6 is 1. I had an x, I took it out. I had a y cubed, I took one of them out, so I've got y squared left. A positive divided by a negative is a negative. 24 divided by 6 is 4. I had an x, I took an x out. I had a y squared, I took one of them out. Okay, a positive divided by a negative is a negative. 192, right, divided by 6 is 32. Had an x and I took it out, had a y and I took it out, so I didn't need to be this long about it. I could just put it right there. Don't forget this negative 6xy and drop it along the way. Now I have a lead coefficient of a 1. So I have a y here and a y here. And I want to know what multiplies to negative 32 and adds to negative 4. So negative 32 is unlike science. So I've got 1 and 32. 2 and 16, 4 and 8. So do any of those multiply to negative 32 and add to negative 4? How about negative 8 and plus 4? There you go. So don't forget that in the description section, there's a link to some practice problems. There's a link to the previous video where we talked about factoring out this common factor. And then there's a link to the next video where we're going to talk about the difference of 2 squares. And then we'll do the difference of sum and difference of 2 cubes, and then factoring by grouping, and then the A times C method, and that's most all of it. All right? And that's it for right now. See you at the next video.